This is Algebra 1, spring test number 13, study guide. We got through lesson 10.1, add and subtracting polynomials. This is part 2 of our study guide, where directions tell us to solve this system of equations. Y is equal to 5x plus 2, and y is equal to 4x. It's set up nice and neatly for the substitution method. You could use the elimination method, but you'd have to do a little work to set it up. This one has an expression 5x plus 2 that we could sub in place of y, since it says that's what y is. So instead of writing y equals 4x, we could write something that says 5x plus 2 is equal to 4x. Now to solve for x's value, we get all of our x's on the same side. Typically, we would bring the 4x over to the 5x side since it's smaller. But since there's a plus 2 on that side, we'll bring this 5x over. It's positive 5x. We undo that by subtracting it. You subtract it on the left, subtract it on the right. 4x minus 5x is negative 1x. That's equal to 2 is still on that side. In order to get x by itself, you divide to cancel out multiplication, and you divide by negative 1 to keep x by itself. If you divide the right by negative 1, do the same to the left. 2 divided by negative 1 is negative 2. That's x's value. It's negative 2. Remember, a solution to a system is not just one value, negative 2. It's an ordered pair, x comma y. So what we have so far is an x value, negative 2. We need a y value. In order to find a y value, you need a sub negative 2 back in to find what x is. The second equation looks a little bit easier. So in place of x, we can plug it in. Y then is equal to 4 times negative 2. Y then is equal to negative 8. So there's y's value. Again, that's not the answer. The answer is x comma y, negative 2, negative 8. This is the solution to the system. That's the point that if you graph both equations, that's the point where they would intersect at negative 2, negative 8. Number 13 tells you to graph this inequality. It's nice and neat, and in y is equal to mx plus b form. So it's in slope-intercept form. Shows us two things. It shows us the slope, and it shows us an intercept. The first thing it shows us is a b value where to begin. On your y-axis, you intersect at 3. So you're beginning right there at 3. Your m, or your slope value, m, tells you where to move. Remember, slope is rise up and down over run left and right. Negative 5 is not in a fraction form, so you have to create it by putting it over the number 1. Now it's fraction form. Everything can be divided by 1 without changing it. Negative 5 either tells you to go up or down. Negative tells you to go down. And positive 1 either tells you to go left or right. Positive 1 tells you to go right. So from where we began at 3, we're going to go down 1, 2, 3, 4, 5, and to the right one time. There's our second point. If this were just an equation, if it just said y equaled 5x plus, or negative 5x plus 3, we would draw a straight line and it would be done. It does not say y equals, though. So what we need to do is we need to do the two things that are different with inequalities. The first thing is it's either going to be a solid or a dashed line. Remember, we look here to determine if it's solid or dashed. Greater than, not, or equal to tells us that it's just going to be a dashed line or a broken line or a dotted line. So through those 2 points, we're still drawing ourselves a straight line, but we're drawing a straight dashed line through the 2. The second difference with inequalities is you have to shade one of the half planes. You have to shade all of the points this way or all of the points that way. We're not going to guess which side to shade. We're going to test one of the points. You can test any point you'd like that's not on the line itself. Remember, the easiest point to test is 0, 0. It doesn't pass through 0, 0. Since it doesn't, we're going to use it. It's easiest to use that one because you can multiply by 0 and easily remember what the numbers are. In place of y, 0 is greater than, in place of x, negative 5 times 0 is 0 plus 3. We have a statement then that says 0 is greater than 3. We have to evaluate the truth of that statement. Is 0 greater than 3? Is the big mouth eating the big number. That's what you ask yourself. In this case, it is not. That is a false statement. That means everything on the same side as 0, 0 is wrong. And since everything on the same side is wrong, that means everything the other way is correct. Number 14 says to write a compound inequality representing the solution, then graph it. We'll graph it simply on a number line. We'll graph it in one dimension instead of a two dimension, instead of a plane. All real numbers at least -3 and at most 3. So here we go. All real numbers at least -3. So x is something -3. At least. That means x has to be bigger than the number 3, -3, or equaled to -3. So there's one of your inequalities. The other one says and at most 3. So at most means that it will not be bigger than the number 3. So it has to be less than, but it can be 3 or equal to. So if this were a compound inequality that had that little word or in the middle, we would throw the word or in between these two and be done. This is not an or inequality, it is an and inequality. What that means is that x needs to be in the middle. So take one of the inequalities, it doesn't matter which one. Typically, you like to put the smaller number first. So if we follow what we say typically, we want -3 to be first. We want x to be in the middle, and we want +3 to be at the end. So now, just follow the two that you wrote originally and follow the one that looks the same. This one here is in the same order as those two there. Since those two are in the same order, that's the symbol we're going to follow. X is less than or equal to 3. In order to make sure you don't make a mistake, make the other one go the same direction. Remember, you'll never have them going opposite directions in an and inequality. If another way to look at it is to just make sure the big mouth is eating the big number for both of them, and you could look at them in any order you want to. So -3 is less than or equal to x, and less than or equal to 3. The other part tells you to graph it. Again, this is a simple one. A graph on one number line, we only need to show two numbers, -3 and 3, because we have those for reference with each other. The first one, less than or equal to 3. That's this one here. I did it in blue to make it match. The arrow is pointing this way. That's the direction you graph. The other one, greater than or equal to, again, a closed-in bubble. The arrow is pointing that way. That's the way you graph. Here is the graph that represents that compound inequality. Number 15 asks you to find the slope. Again, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Your change of y, -3 minus 6, over your change of x, 8 minus 3. That is how you find the slope. -3 minus 6 is -9. 8 minus 3 is 5. Those don't simplify any further. Therefore, your slope is -9 over 5. Write an equation parallel to this line that passes through the given point. Y is equal to mx plus b. Gives it to us nice and neat in slope-intercept form. Parallel lines have the same slope value. If you draw them, you can see they have the same slope value, m value. Therefore, the m value of the new line will be 2, because that's what the m value of the other line was. It says it passes through the given point, 1, -16. So we're given a slope and a point. So we'll use point slope form. Point slope form, y minus y sub 1 is equal to m times x minus x sub 1. In place of y, we'll leave y. We'll fill in for y sub 1. We'll fill in for m. We'll leave x. And we'll fill in for x sub 1. M's easy. You plug in the value 2 just like it is in place of M, 2. The x sub 1 and y sub 1 come from that point 1, negative 16 that you're given. This is your x value. This is your y value, but you're going to use the opposites of the values given. In place of y sub 1, it says negative 16. We're putting in plus 16. In place of x sub 1, it says 1. We're putting in negative 1. Here's your equation. Y plus 16 equals 2 times x minus 1. Number 17 says simplify this equation. Negative 3.8 to the 0 power. Remember, anything to the 0 power is 1. Negative 7 to the negative 2 power. This is being raised to the negative 2 power, not negative out front. Therefore, negative 1 is going to stay on top. 7 is going to go down since it rides the elevator, and it's going to be raised to the positive 2 power. Negative 1 over 7 squared is 49. Negative 4 is being raised to the negative 3rd power. So 1 goes at the top, negative 4 goes down, and it's raised to the positive 3rd power. This is an odd numbered exponent for a negative number. Therefore, at the end, it's going to be negative 1 over a negative value. 4 times 4 is 16. Times 4 third time is 64. Negative 1 over 64. 2 times g to the negative 2 over d to the 5th. Only g is being raised to a negative exponent. Therefore, 2 stays on top. D to the 5th stays on top, and G to the negative 2 rides the elevator down and becomes raised to the positive 2. 2D to the 5th, G squared, over G squared. Number 21, 7 over G to the negative ninth, H to the ninth. G is the only thing being raised to a negative exponent. So 7 is going to stay right where it is, and h to the ninth is going to stay right where it is. But g to that negative number is going to ride that elevator. So g to the negative ninth has to go up, and it becomes g to the positive ninth. 7g to the ninth over h to the ninth. 4 times 2 to the negative fourth. Remember, exponents have to be done before multiplication, so that's got to ride the elevator and go down. 4 over 2 to the positive fourth. When it rides that elevator, it becomes positive. 2 to the fourth. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. 4 over 16. There's one more step to do here because 4 and 16 both go, they have a number that goes into this, to both of them. 4 goes into itself once, and then the 16 4 times. So reduce that fraction, 1 over 4. 5 to the negative third times 6 to the 0 power. Remember, anything to the 0 power is 1. 5 to the negative third has to ride that elevator, become 1 over 5 to the positive third. So 1 over 5 to the positive third, 5 times 5 is 25, times 5 is 125. So 1 over 125. All of the bases are the same for number 24, 2, 2, and 2. So add the exponents. 2 to the negative 9 plus 8 plus 1. Anytime you multiply bases, you add exponents. Negative 8 plus 1 is negative 1, and negative 1 plus 1 is 0. 2 to the 0 power, just like that one a minute ago, anything to the 0 power is 1. Both of these have the same basis, 4.15 and 4.15, so add those exponents. 4.15 to the negative 8 plus 9 is 4.15 to the first power. Remember, anything to the first power is just whatever it is. 4.15 is the solution. 3, h to the 8th times h to the negative 1. 3 times 1, if you need it, is just going to be 3. And h and h are the same basis. H to the 8th plus a negative 1. Remember, plus a negative 1 just means minus 1. 3h to the 8th minus 1 is 3h to the 7th power. 7x to the negative eighth times 6x to the third. Again, multiply the two coefficients, 7 and 6, to get 42. And then you're multiplying the bases, x and x. That means to add the exponents. X to the negative 8 plus 3 gives you 42x to the negative fifth. Remember, you can't leave a negative exponent like this. So it's got to ride that elevator. Only x is being raised to the negative exponent. So only x is going to ride that elevator down. 42 is going to stay on top. X rides that elevator down and turns into the positive fifth. 42 over x to the fifth. 28, negative 6x to the fifth times 2y to the 10th times 2x. Multiply all of your coefficients. Negative 6 and 2 is negative 12, and negative 12 and 2 is negative 24. Then multiply the same bases. You have x to the fifth, and you got x. Remember, that has an exponent as well, 1. When you multiply the same bases, x and x, you add the exponents, x to the 5 plus 1. There's only one y on there, y to the 10th. So that one's not going to change. It's just going to be y to the 10th. So your solution then is negative 24, x to the 6th, y to the 10th. And this is all we can do with this problem. Nothing's raised to a negative exponent. For 29, you're raising a power to a power. So you're going to multiply right here. K to the 8 to the second. You multiply 8 times 2, and you get k to the 16th. For number 30, you got k to the negative second to the sixth. Again, multiplying, raising a power to a power means to multiply them. K to the negative 2 times 6 gives you k to the negative 12. At this point, though, you have something raised to a negative exponent. You can't do that. So it has to ride that elevator. Remember, everything's over 1 if there's no fraction. So 1 stays on top, k goes down, and it turns into a positive exponent, 1 over k to the 12th. Number 31, x to the ninth to the 0 times x to the 7th to the second. Remember, anytime you raise a power to a power, just like the last two problems, you multiply the exponents. So we have k to the ninth times 0. That's going to be k to the 0 power there. And we have x to the 7th to the second. That means 7 times, this is x, excuse me, not k. I'm looking at the wrong problem. It's still going to treat it the same way. X to the ninth to the 0, which gives you x to the 0, and x to the 7th to the second, which means you multiply 7 times 2 and get x to the 14th. Remember, anything to the 0 power is simply 1 times x to the 14th. And there's no reason to write 1 times something. You're left with x to the 14th. Number 32, negative h to the 4th to the 3rd. H to the 4th, that says to the 5th power, not the 3rd. Sure. Yep. 4th to the 5th. Again, a power to a power, multiply them. Negative h to the 4 times 5 is negative h to the 20th power. 5k to the 8 to the 3rd. Both things inside of the parentheses get raised to the 3rd. 5 gets raised to the 3rd, and k to the 8th gets raised to the 3rd. So you multiply 8 times 3. 5 to the 3rd again. 5 times 5, 25. Times 5, 125. That's an easy thing to raise to the 3rd power. K to the 8 to the 3rd, multiply 8 times 3. K to the 24th. 125k, 125 times k to the 24th. Everything gets raised to the second power here. 3 gets raised to the second power, x gets raised to the second power, and y to the 3rd gets raised to the second power, which means it multiplies times 2. In the second parentheses, everything gets raised to the 6th power. X does, and y does. So now we have 3 to the second power, which is 9, x to the second power, y to the 3 times 2 is 6 power. We still have x to the 6th and y to the 6th. So now we have one coefficient, 9. That'll stay just like that. And we have same bases, x and x. So you add 2 plus 6. And we have y and y. You add 6 plus 6. 9x to the 8th, y to the 12th. Negative 3k to the third, j to the third squared times k to the third, j to the fourth to the eighth. Everything gets raised to the second power there. Negative 3 does, it gets raised to the second power. K to the third does, 3 times 2. And j to the third, 3 times 2. For the second one, I'm going to have to do it below it just because I'm running out of room. K to the third gets raised to the eighth power, so 3 times 8. And j to the fourth, 4 times 8. So for that first one, negative 3 to the second power, negative times a negative is a positive 9. K to the third to the second becomes k to the sixth. J to the third to the second becomes j to the sixth. Then on that second one, k to the 3 times 8 is to the 24th. J to the 4 times 8 is 32nd. So we got a lot of big numbers up here, but it's simple at this point. You just add them. So same basis. Again, only one coefficient, 9. You have k and k, so you add the exponent, 6 plus 24. And j and j, j and j, so you add those exponents, 6 and 32. So finally at the end, a lot of work to get to it, 9k to the 30th, j to the 38th power. 9k to the 30th, j to the 38th.